Hi everyone, this is Ms. Martins. I know we didn't have a chance to finish the lesson I had planned, and so rather than get behind, I thought I could make a short video to help us catch up and make sure that we're all on track. So I know we finished up around here. We talked about how any 2 points are collinear even if they're not drawn that way. And likewise, any 3 points are coplanar even if they're not drawn that way. It's just a property. There's always a line that could be made between 2 points, and there's always a plane that could be drawn in between 3 points. So that's where we ended. We're going to start now talking about a couple other features that you're probably quite familiar with. A line segment is part of a line that has 2 endpoints. Sometimes people call it a line that stops at both ends. I think that's kind of a lame definition because lines don't stop. So really a segment is a piece of a line and it has 2 endpoints. Line segments are labeled by these endpoints. So this segment below can be named segment AB or BA. Okay, there's a little hat over it. That hat can be considered a bar. Okay, so notice that the bar over the endpoints has no arrows. That's really important because it helps distinguish a segment from a line. Okay, the order of the endpoints doesn't matter. Whether you go from A to B or B to A, it's covering the same distance, so it's defining the same line. Okay. Going on, a ray is a part of a line that has one endpoint, but it extends forever in the other direction. So you can think of this kind of like a ray of sunshine. So a ray of sunshine starts at the center of the sun and it goes forever until something obstructs it. Okay? But if there were nothing obstructing its path, that ray of sunshine would continue on forever. So a ray is labeled by its endpoint and one other point on the line. Okay? If you haven't noticed so far, I've tried to underline the words that you need to complete. So that should help you finish this quite quickly. Okay, it may not be perfect, but it should be pretty close. So of lines, segments, and rays, rays are the only one where order actually matters. When labeling, always write the endpoint under the side without the arrow. So if you look at this example, ray CD can be written as such, starting at C, going through D and on to forever. And then your notes say it could be written as CD going the other way, okay? It is technically correct, but I don't love it, okay? It technically starts at C and then heads the other direction towards D and on to forever, but our textbook really doesn't use this notation, so I'd really prefer if you write it with the arrow to the right-hand side. Just makes things a little cleaner. Okay, so I crossed it out on mine. If you want to keep it on yours, that's fine too, because again, the endpoint is at C, so as long as the arrow is not above C, it's okay. So technically that second option is acceptable. Okay, what would not be okay is, for example, if you were to write DC with an arrow headed to the right. Okay, you can't put an arrow over the C in this example. That would be completely unacceptable and it wouldn't represent this picture whatsoever. Okay. An intersection is a point or a set of points where lines, planes, segments, or rays cross each other. Okay. So in example 5, how do the figures below intersect? I'm going to try and release these answers as we go through them. So in the first picture, we've got a line crossing another line, and there's an intersection where they cross, and it looks like a point is that spot where they cross, and it's called point P. Okay, we're giving it a different name every time.
Good afternoon. We have a thunder and lightning storm coming in, so if you're getting picked up at 4:30, could you come and wait in the dining room, please? Thank you.
So that was Mr. Reese. We're going on. We've got a line and we've got a ray that intersects it. Again, it's crossing at a point, and we name that point Q. Okay, in the third picture, we've got a plane intersecting a line, and that line crosses at R. Okay, so it might not look like it. It might seem kind of counterintuitive that something as big as a plane and as small as a line can cross at a single point. But if you think about it, imagine a piece of paper and a pencil, and you jab that pencil through the piece of paper. You would wind up with a small hole in your paper, and that hole is the intersection of where your pencil crossed that plane. So think of R like the hole in your paper if you were to get a pencil and stick it through. Okay. Then we've got, in the fourth picture, we've got one plane that's green intersecting a pink plane. okay? And they cross not at a single point. There's actually many points, an infinite number, in fact, of places where they cross. Remember that it looks like those are 2 sheets of paper, but each of those sheets of paper is going on forever in all 4 directions, okay? So I want you to think about this almost like the binding of a book, okay? The binding of a book looks a lot like a line. Okay, in real life, it's a line segment, but if your pages were infinite, it would look more like a line as opposed to a segment. Okay, so in figure 4, 2 planes intersect to form a line, and in this case, we named it L. In the last picture, right over here, we've got 3 planes that are intersecting each other. One's green, one's pink, and one's blue. Okay, in this specific arrangement, it looks like there's only one point where they intersect. Okay, that point is named S. Now, I challenge you to think of other ways that you could create intersections between 3 different planes. Okay, this is not the only way that 3 planes can intersect. So this is a nice thinker question, and I encourage you to come to class with some ideas of how you could arrange 3 sheets of paper such that it creates different possibilities. Okay, continuing on, let's look at example 6 and answer the following questions. Okay, how did the 2 planes intersect? Well, we've got a pink plane and we've got a green plane. Just like we learned above, there's going to be a line where they cross. And that line is right about here if you can see my cursor. Okay, it's not labeled, but it would be right here. Okay, continuing on. Is line L coplanar with plane V or W? Okay, is L coplanar with V? Nope, it would have to be resting on that plane in order to be true, and it's definitely not. It's crossing it at point R. And is it coplanar with W? Well, it doesn't look like it's resting on W either because it crosses at point Q. So in that case, I'm going to say no. Okay, it's not coplanar with either. Continuing on. Are R and Q collinear? Well, I can see right now line L includes R and Q, but even if that weren't drawn into the diagram, I know that it would be true because any 2 points have to be collinear, so yes. Continuing on, what point is non-coplanar with either plane? Okay, so I'm looking for a point that doesn't sit on either the green plane or the pink plane. Well, that's S. Okay, last but not least, list 3 coplanar points in plane W. So I'm going to head up to plane W, which is pink, and I'm looking for 3 coplanar points. Okay, so the points that are sitting on plane W are Q, T, O, and P. So be careful, U is not on plane W, U is technically on plane V, it's on the green plane. M is not a point, M is an italicized lowercase letter that represents line PO. And W is not a point either because W is in the corner naming the pink plane. Okay, so as long as you pick any 3 points out of Q, T, O, and P, you should be all set. Okay, so P, O, T, and Q, pick any 3 and you're golden. Okay, so then what we would have done in class is we would have done something called a skewer challenge. Okay, and a skewer is basically that piece of wood where you would have some shish kebab, right? It looks a little something like this. And so I would hand out to every student 2 of these skewers. And I would say, my challenge to you is to arrange your skewers, 1 in each hand, such that your skewers are not parallel, but they also will never intersect. Okay? So they never intersect and they're not parallel. So if you're at home, go grab maybe 2 pencils or 2 straws, or if you happen to have 2 skewers, go grab 2 skewers, okay? And see if you can figure out how to arrange them 1 in each hand such that it satisfies both criteria, okay? It never intersects, but it's also not parallel. So pause this video, give it a try, and then resume it when you're ready. So at this point, hopefully you've tried the activity. Maybe you've found some success, maybe you haven't. But what you hopefully have seen is that there is a way to arrange them without being parallel, and that even if those skewers were infinite and went on forever, they would never, ever, ever touch, okay? And it would look something like this, okay? You might have AB headed in one direction and CD headed another direction, okay? They need to be in different planes. That's the moral of the story. As long as you create your 2 skewers to be oriented in three-dimensional space such that they're in two different planes, they can be non-parallel and still never intersect. Okay? So lines that are not parallel and never intersect are called skew lines. And that's kind of why I like to do this with skewers, because it helps you remember the name. So that's all I had planned. And I think now that you've gone through all this material, you should be in good shape to handle the review questions. So I encourage you to look at LMS, because I am going to allow you to skip a few questions. So please feel free to email me if you have any questions, and I hope that this was helpful. Thanks so much for your time.